the integral. Then we use a definition to evaluate the integral. When the integral has a geometric meaning, that's called the signed areas, the sum of the areas between the graph and the x-axis. If the region is below the axis, the area is negative. If the region is above the axis, the area is positive. So the signed area, add them together, maybe cancel out, get 0. Okay? But you cannot always use a definition to evaluate the integral. Okay? Just like you can always use definition to evaluate the derivative, find the derivative of the function, right? Take the limit. Some simple function, yes, you can do that. For example, on the final exam, I will put like a square x. Find the derivative of square x using the definition. Then you have to use the definition, okay? But like x squared plus x cubed and divide by x and find the derivative. I'm not going to ask you to use the definition, right? You have to use some formulas or product rule, quotient rule to find it. So similarly, we can do that for the integrals. Integrals, yes, we have the definition for the integral, okay, but we are not going to use that to find to evaluate the integral, okay? So the integral, recall that. What's the definition, right? Definition, simple. Definition of the integral, right? The integral of the function is going to be the limit of this Riemann sum, okay? And the limit is when delta xi goes to 0, okay, uniform. If the function is continuous, the Riemann says that, okay, this can be simply just look at the special partition, okay, delta x. Okay, so delta x goes to 0 means n goes to infinity. Delta x is going to be b minus a of n. Xi is going to be a plus I delta x. This is true if f is continuous. Okay. Otherwise, you cannot use this form. Okay, if f is continuous, that's special. So you can evaluate the definite integral is this. Now, then we have the so-called theorem, called the average value theorem. Okay, the theorem says that if f is continuous, okay, on the interval from a to b, then this average value, okay, is going to be equal to the value function for some c in the interval from a to b. Okay, the left-hand side is the average value. The right-hand side is the particular value of the function. Okay, so to prove that, we just prove this is the upper bound, lower bound. The upper bound is the maximum value of the integral, and the lower bound is the minimum value of the function. So upper bound is the maximum value of the function. We are going to use this to get the following theorem. Okay. So here's the theorem. This is a very important theorem. So if f is continuous on the interval from a to b, then this f of x, integral from a to x, f of t dt, okay, is an antiderivative function. Wow. Okay, so i.e. the derivative of the function is just equal to f of x. That's great. Okay, so if this is true, then you can conclude, because an arbitrary antiderivative of this function f of x is just this one plus another constant. Okay. Yeah. So you conclude that from here. You conclude what you conclude. You already find one antiderivative, right? Then you conclude that for any antiderivative of f of x, say g of x, okay? Yeah, just use that. Okay, I'm going to use so this is a special one. I put the f naught, okay? Make a difference. So any general antiderivative f, okay? Then you have the following result, okay? Because it's this phrase is an arbitrary antiderivative, okay? Then first of all, f of x is just f of naught, right? Different by constant, right? That's okay. Everybody knows that, right? Because they have the same derivative. Then you look at the difference, okay? The difference is f of b minus capital F of A. Because they just differ by constant, right? And you look at the definition. This is nothing but this integral. So this is called the first fundamental theory. That means for an arbitrary antiderivative function, okay, the integral of the value integral is going to be the difference of the values of antiderivative at the end to end point. Okay. In other words, the integral of the function is going to be the value, the difference. This means the difference of value to end point. Okay. Okay, which is f of b minus a. So the key point is to prove the above one. Okay, the integral from a to x is the antiderivative of the function. Okay. So let's prove it. Yeah, I'm going to prove this stuff. Okay, I'm going to prove of this stuff. Why the derivative of that is going to be f of x? The proof is very simple. Okay, the proof is the derivative, right? You just need to look at h divided by h, right? Just limit is going to be. Right. So what is that? You assume h is positive. If you assume positive, and this is going to be the integral from a to x plus h, and here's the integral from a to x. Okay. When you look at the difference, see this integral from a to x plus h, this a to x, differ only by, but the integral has a foreign property. You can separate, right? A to x plus x to the x plus h. Right? Then you minus the last one. So this cancels out. You only get the integral from x to the x plus h. Remember, this is the interval from x to the x plus h if h is positive, right? Just assume h is positive, okay? So this is the integral of the function. This actually is the average value function over that interval. And then we know this is going to be the value of the function at some point c. Okay, c depends on h somewhere here. Now you let h go to 0. X is fixed because this clearly f approaches x as h approaches 0. Because when h approaches 0, x is fixed. Then the interval is getting smaller. That pushes c approach x. That's why, because the function is continuous, that's why f of c approaches f. So my conclusion is the derivative of that function is just equal to f. It's great. All right, so the integral gives you the entire derivative of the function. Once you get this, then an arbitrary entire derivative, okay, for the function I show you, only different to this, right? So in other words, if f is an entire derivative, arbitrary entire derivative of the function, right? Then can express f as the integral of this function and plus constant, okay? For some c, that's what it says. Because all the entire derivative of the same function differ by constant. Now you already find the what, right? The integral from a to x is the entire derivative of the function. Then an arbitrary entire derivative is equal to that function plus some constant. Okay, and that implies the difference of the function at the two-ended point is just equal to the value of the function, the integral. Okay, because the integral from a to a is going to be 0. From a to b, it's just, just takes the difference, then you can get that. Okay, and this is just f of b minus f of a, because when f of b minus f of a, and then you will see c will be gone, c cancelled out. Okay, yeah, let's look at it, right? F of a minus f of b, what do you get? F of a is from 0 to f of b, right? You see? And f of a, right? And clearly CC cancelled out, and that is going to be 0. That's why you end up with the integral of this. Okay, great. So for this theorem tells us if you're able to find the antiderivative using different method, not to use the integral, okay, then you can evaluate the integral. That's it. Okay, great. Right. So think about this, right? This integral of from 0 to 1, right? And then we say x cubed dx. I know this is the area of the function under that graph, okay? This actually is going to be the area of the region. And y equals x cubed, and x is between 0 and 1, right? But how can you find it? You use a definition, you can find out, no problem. Right? Use a definition. If by definition, this is going to be limit as n approaches infinity, and xi is a I n, okay, cube. Then delta x is 1 over n, okay. So you can find it, okay, no problem. This is a Riemann sum, the limit of Riemann sum, okay. So you partition here 0 and 1, right? So this is xi, which is I over n, okay. Then you use a formula, you can evaluate the integral, okay. So by definition, it's going to be, this is n to the 4th power, and the sigma of I square is going to be n plus 1 over 2 and the square, okay. The answer is just quarter. You can find the limit. So that's called, you find the evaluate integral by definition. Now, you look at function, right? Okay. The entire derivative is going to be 1 over 4 x to the 4th power. This is the antiderivative. Okay, so f prime x is going to be f of x. According to the above argument, the integral from 0 to 1 is just the difference of the value of the antiderivative between the points, okay, which gives just a quarter. Right, so you get the same answer, so quick. I don't need to find I just need to find the antiderivative of the function. Okay. So what is yeah, let's say what is this? Right? We remember we define this to be x, right? Yeah, we can calculate, right? So the antiderivative t cubed is just still at 1/4, right? And I'm going to use a t instead of x, otherwise confused. So evaluate the two endpoints. This is also, yeah, just this is antiderivative, right? It's the antiderivative function. Now using this formula, we can find we can evaluate integral of many functions. Right? For example, yeah, evaluate the integral from 0 to 4x 4 minus x dx. Okay, this is going to be the area of that region. Okay, and the function here is x 4 minus x. Right? So x times 4 minus x is the function, and the two endpoints are on the x-axis. To evaluate this integral, if you have to find the area of that region, right, under this parabola, you have to evaluate this integral. So how do you evaluate this integral? You can use a partition, eliminate sums, find a limit. It's no problem. But that's pretty complicated. So what we can do is we just find the entire derivative of this function, x times 4, yeah, x times 4 minus x. If we were able to find antiderivative, one antiderivative, that's enough. This is going to be 4x minus x squared. It's a polynomial. I think the antiderivative is easy to find out. Just find the antiderivative for each of them. All right. 4x squared is actually 2x squared, the antiderivative. And x squared, the antiderivative is 1/3 x cubed. Right? So we get antiderivative. Then the integral of this function is just the difference of the values at the two endpoints. So I'm going to put 4 squared minus 1/3, 4 cubed minus 0, because the rest of them is 0. When x equals 0, this is 0. 32 minus 64. Okay. So you can simplify it. All right. So the answer is 32 over 3, I think. Right? $96, yeah. So this is answer. Okay, it is the area of that region. You just need to find the antiderivative, then you can evaluate integral. Okay. So the integral from 0 to x of the function is an antiderivative. That's a key point. All right, let's go back to the problem. Okay, you let g of x is going to be integral from 0 to x squared. Okay. Find g prime x. Actually, this is a composite of two functions. Okay, so you can let f of u to be integral from u to the 1 minus square x dt. Okay, square 1 minus t squared dt. We know f prime u is going to be just 1 minus u squared, square 1 minus u squared. Okay, because this is the antiderivative function inside. So our g of x is actually just f of x squared, right? Replace u by x squared. Okay. So when you differentiate with respect to x, you differentiate f with respect to u, right? Then you differentiate x squared. So you will get 2x f prime x squared is going to be you know, f, just replace u by x squared. So 1 minus x squared and squared. Okay. Without the, yeah, was, you know, you have to modify, right? So if you let g of x to be x 0, right? 1 minus, yeah, there's some properties of integrals. Before we talk about this, we need to discuss some basic properties of integrals. Some basic properties of integrals. If the function is integrable, right? So the first one is if f is integrable under some interval, means yeah, integrable on the interval from a to b. Okay, and the number c is between a and b. Then f is integrable on each subinterval, and then also equals that equal. Then f is integrable on the interval from a to c and from c to b respectively. Okay. And not only that, the integral of the function, we use this property before already, I have to mention that, is going to be the integral of this function plus integral of that function. Okay. You can separate. I think the proof is obvious just using the Riemann sum, because sum can be separate. Okay. So the picture looks like that. Okay. The integral of the function over this whole interval can be separate. Integral can be separated into two integrals, just like an area together, right? what is total area of the region, and there's a graph. But if you can calculate the area and each on the left side and on the right hand side, add them together, right? So you can do that. It's the same here. If you're able to find the area on, for the region on the left side and for the region on the right hand side, add them together, then that should be the total area. Okay, so it's pretty reasonable, right? Second, we have to make a condition. So if we have to make some notation assumption. So if normally A is smaller than B, okay. So if if A is smaller than B, but our integral from B to A, okay. How do you define that? We define this to be negative here. Okay, but this is defined because it's the interval from A to B. So in other words, like 3, 1 f of x dx should be understood to be integral of the function from 1 to 3. Okay, but if you have to put a negative sign in front of it. All right, so let's take a look at the example. Find the derivative of 1 x f of t dt. Okay, we assume that f is function is continuous. Okay, so this is first of all, this is going to be negative from 1 to x f of t dt. Then you apply the formula, it's negative sign. Then this is just f of x, negative. Okay, you can take a negative sign out. But how about the derivative of from 1 to 2x? Okay. One to 2x is going to be it's composite of two functions. Now, if you can use a substitution, okay, to evaluate by the chain rule, okay, if you want, right? So how do you do that? So if you have, right, dy, right, it's going to be du y du dx, right? That's the chain rule. So our u is going to be 2x. So that is going to be the derivative of this, then differentiate with respect to x. All right, this is just f of u, and the du over dx is just equal to. Right, so that is answer. All right, one more. Find the derivative of x and x squared. Okay, the both changes. How can I do that? So you have x and x squared, right? How do you differentiate this function? This is function. If I give you a very specific number, a specific function you can evaluate, right? So right now, I do not mention what is f. How to, the only formula you can use is the following one. The derivative u from a to u f of t dt is going to be f of u, okay? This is the only formula you can use. You cannot just create a formula by yourself. We discovered that it's not created by a mathematician. Of course, it's the symbols we introduce. You know, we introduce the symbols like x, f, right? But it's there. So if you can, a scientist always have dreams that can talk to the God. You got hundreds of Nobel Prizes because you know, right? God tell you, okay? So you can then go ahead to do the experiment and get a result. But you don't know, right? You cannot talk to it. That's the point. But some people do have this talent. Like I can see it, it's true, then go ahead to do experiment, okay? Right. Some people, yeah. Okay. But it's harder to tell. Different people have in different areas have different talents, right? If you give a geometry problems like you know, to some kids, and different kids that do the problem different, okay? Some kids like attach triangle to a square. So this looks like a trapezoid. Some kids will use a trapezoid formula to find the area. Some kids will just divide it, draw a line and say, hey, this is a square, this is a triangle, add them together. So that different way, you know, different people have different education background that come up with different solutions. All right, so this one, how can I do that, right? You have to solve the problem. This is a problem, okay? And sometimes you look at textbook, I couldn't find any formula, right? All right, so the way we do this is very simple, okay? We have to modify the integral. I just add 1 or any number, okay? Okay, then it's almost similar to the formula over there, but I also have to change the order. It's negative from a to x, f of t dt. Okay, then you can differentiate the first one with respect to x, you just get an f of x. The second one, when you differentiate, you get f of x squared, just put x squared into f, but don't forget to differentiate x squared. So that's the answer. Okay. And here we apply the chain rule. So this is actually from here to here, you need to use a chain rule. Okay. Right. So the next problem, find the derivative of 1 sine x sine t dt. All right, so now you have two different ways to solve. One is you evaluate this integral. You evaluate this integral, and then you differentiate. But the simplest way to do is don't evaluate integral, just write an answer, right? So this is going to be, okay, is a chain rule, right? So you give me sine t replaced by sine x, then you differentiate sine x to get cosine x. So this is the answer. Okay. Now, you can evaluate this integral. Okay, the entire derivative of the integral is going to be sine t. The entire derivative is negative cosine t. Okay, so negative cosine t. Entire derivative of sine t is negative cosine. Evaluate the two endpoints. So this will be cosine sine x minus negative cosine 1. Okay, it's constant. So it's going to be negative cosine sine x plus cosine 1. Okay, so this the function. Okay. Now when you differentiate, you differentiate this function. The second is constant, right? So you don't need that. Negative cosine x, when you differentiate, you get sine. But you have to differentiate sine x, that's why you get cosine x. So you get same result. But you're lucky here, we can evaluate the integral. But sometimes you cannot. Or it's complicated. You don't need it. Just apply the formula. Yeah, you can get evaluated. You can get the derivative. All right, so let's go back to the integral. Evaluate this integral. All right, here k is now going to be k is greater than -1. All right, so entire derivative of this function, capital Fx, is going to be 1 over k plus 1 x to the k plus 1. Because this is an entire derivative of the function. So the integral is going to be the difference of the values at 2 endpoints. So that is just equal to k plus 1. 1 over k plus. It's interesting when k is increasing and the integral is decreasing. That makes sense because if you draw the picture here, guys, this is a y equals x squared. Right? Now, what is y equals x cubed? This is y equals x cubed. So if we increase the value of k, you push down the curve, but with the 2 endpoint fixed. Okay? When x is sufficiently close to y, the y value is sufficiently close to y. So those 2 endpoints fixed. But then when you increase the value of k, push down the bar. So the area is getting smaller and smaller. Okay, the area is getting smaller and smaller. Okay, so the area, you see that's 1 over k plus 1. This is going to be the area and the region y equals x to the power k. The size still problem. When we talk about size, depends, right? Sometimes we take the area. Area should be more precise. But in some cases, you have to talk about volume. Like compared to pizza, right? You know, like some are very slim, very thin, some are very thick. Then you have to talk about volume. But you cannot say, oh, this is 6-inch or 7-inch size pizza, right? So that's why the volume is introduced. If the second is the same, then you only talk about the area. So when we talk about size in mathematics, I think it means the diameter, not about the area. Okay, when we talk about how big of the pizza, it's harder to tell. They are talking about size or the talking about the area, right? It could be very long pizza, but it's only a tiny bit. Okay. So normally in mathematics, when we say size, we mean the one-dimensional measurement. Okay, how the size of the universe just makes a diameter. Okay. All right, so we can now easily evaluate the integral, and we can use that to find the area of the region, right? And some graph, okay? Before we call it, some people can invent the calculus, right? And we do have trouble to understand the area of the circle. Okay, I'm going to show you now. Area of the circle will be a piece of cake to find out once we learn the calculus. Okay, but I still cannot do it right now because it depends on how do we find the area, right? How do we describe the curve? Okay, the curve, the semicircle. Okay. And we are still not able to evaluate such integral, but for polynomials, we don't have any problem. Such like this problem, integral of x to the fourth power over x squared dx. And yeah, this is function is defined, right? And it represents the area under the graph of this function, okay, above the x-axis. So let's try to evaluate this integral. Right, so the function f of x is going to be x, can be written as the sum of two power functions, x squared plus x to the negative 2. So the entire derivative of this function will be 1 over 2 plus 1, x to 2 plus 1. Okay, so simplified, you get this. This is an entire derivative. It's very easy to, as long as it's a sum. As long as it's a sum of, as long as it's a sum of power functions or sum of like trigonometric functions, we are able to find the entire derivative of this function. Okay. So this is the entire derivative of the function. Therefore, the integral is going to be 1/3 x cubed plus x to the negative 1. It's evaluated at 2 endpoints. Okay, so in other words, okay. And let's simplify. 8 over 3 minus 1/2, 1/3 minus 1. Okay. And we will get 8 minus 7. And minus 1/2 plus 1 plus 1/2. And 17. 14 plus 3, 17. So 17 over 6. It's very close to 3. Okay, so this is answer. We get the exact value. the next problem. Integral from 0 to 1 square of x 1 minus x dx. It's product two functions, right? As long as we are able to find the antiderivative, then we can evaluate this integral. The geometrical meaning of this, let's look at the function, right? Y equals square of x 1 minus x. Okay, it starts from, it's 1, 0, x axis. When x equals 0 to 0, when x equals 0, when x is between 0 and 1, it's positive, so it looks like that. So this tells you the area of this region. Okay, it tells you the area of this region. The question is, what is the area, right? So if you find the entire derivative of the function, then you can you see, that's the reason we want to start antiderivative first before integrals, right? It's between integral and the derivatives, right? Section 3.9. Okay. So we got yeah, you have to write this in the form at this. Now sometimes you can skip some steps. Just find the antiderivative of this function. The antiderivative of this function is going to be 1 over 1 half x to the 1 half plus 1 minus 1 over 3 over 2 plus 1 x to the 3 over 2 plus 1, and then evaluate the two endpoints. Okay, so you will get 2 over 3 and the 2 over 5 x to the 5 over 2. Okay, so just plug 1 for x, you get the answer. Okay, when you plug 0 for x, you get 0. So you will get, you only need to look at the coefficient, right? 15, 10 minus 6. So it's 4 over 15. 4 over 15 is the area of that region. See, it's so easy, right? As long as the function is a sum of power functions, we are able to do it right now without going through the limits, right? But later on, we have to find a new way to evaluate the integral. Okay, when we have to deal with more complicated function. And what kind of function we have to do it? Suppose you attempt to find the area of the circle, semicircle, right? Right, area of the semicircle. That was radius r, right? And this is going to be r squared minus 6 squared. So can you evaluate this integral, right? Okay, this actually gives you the area of semicircle, right? The half of 1 half of the area of the circle. Right? Was the radius r. Right? It's not a sum of the, it is not the sum of quadratic function, power function, power function. So I'm not able to use any existing formula to evaluate this integral. But this is very important because this gives the area of the circle with radius r, right? We cannot do it right now. We're going to learn some new methods in the next class. So first, then we're able to evaluate this integral. I think some part of the material even go to move to delay, postpone to next course section. This is course math 166. Okay, use other type of substitutions. Yeah. Use some kind of substitute to evaluate its integrals. So I'm not going to do that. We cannot solve it, okay, right now. Okay, we have to learn more. Okay, but let's look at the function, piecewise defined function. This is let's use a 4, okay? And I'm going to put 4 here. X is greater than less than 2. So this function is defined piecewisely, but it's continuous, right? So the integral, evaluate integral from -2 to power 2, f of x dx. How does the graph look like? Here's 2. When x equals 2, it's 0. When x equals 0, it's going to be 4. All right, this is a picture. So you need to find the area of that region, right? So the integral represents the area of that region. Integral represents the area. The question is, how can I find the entire derivative of a function which is defined piecewise? Okay. That's okay now. We have to use the property of integrals. We have to separate. Then on each interval, the function takes a special value, 4 here, dx. And plus integral here is a 4 minus x squared dx. Okay. Then we are fine, right? The entire the integral of a constant 4 from -2 to power 2, which is going to be the 8. And the entire derivative of 4 minus x squared is the 4x minus 1/3 x cubed, and evaluate 2 endpoints. Right? So it's going to be 8 plus 8 minus 1/3, 2 cubed, which is 8. Okay. How can I simplify? Well, I can still write to 2 times 8 minus 1/3. 2 minus 1/3 is a 5/3, right? Yeah. Times 8, 40/3. Let's do this. Yeah, 40/3 is that. So we can evaluate this definite integral if the function is piecewise defined. Right, let's do one more, then will be enough. So integral from 0 to 2, u minus 2, u plus 1 du. Okay. Now the variable can be arbitrary variable, right? So this is a polynomial actually. It's a product of 2 functions, 2 polynomials. So we cannot use a no product rules here for integrals. Okay. So what you do is just multiply this out. You will get u squared negative 2u plus 1 minus u minus 2. So express as a polynomial, right? then you can find an antiderivative, right? You find an antiderivative for each of them. Okay. And you simplify. Okay, you plug 0 for u and get the 0 everywhere. So you plug 2 for u, then you get 1/3, 2q minus 1/2, 2 squared minus 2 times 2. Okay, so let's simplify it. That's 2 minus 4, right? Uh, 8 over 3, 6, 18. So the answer is negative 10 over 3. It's negative now. Why it's negative? You know, when you get a negative, you have to go back to look at the function. Is the function negative on this interval somewhere? I think yes. U plus 1 is positive, but U minus 2 is negative everywhere. That's why you end up with a negative answer. Okay, so make a simple observation when you're done with it. Okay, of course you say, I'm nervous, I was take the test, and you probably forget, but that's still routine check. It's a checklist. You know, when you have a time, double check. Okay, that will help you to avoid mistakes. Okay, some students done like this. They write all the few formulas on the piece on the first page of the exam because they're worried about when they get nervous they forgot the formula. That's also a good idea, you know, right? But whenever you get the answer, you look at the answer. Is it reasonable or not? Right? Makes sense, right? And then, oh, it's negative. Then the function must be negative somewhere. But if you look at the function, we u between 0 and 2, current. So u minus 2 is negative. That's cool. That's fine. Okay. It's not easy to get 100% correct. I know that some students still feel they can get 100%, only get a 99. Okay, because it's hard. You know, it's not because of your knowledge. Sometimes your mood, you know, your mental healthness, also, you know, all kinds of things contribute to whether you can get 100% correct, even if you know everything. Just like me, when I show you all the works, then sometimes you might copy the number wrong. Okay, then I end up with the wrong answer. Sometimes I can catch it. Okay, oh, that's impossible. But sometimes you cannot catch that mistakes. Okay. But if you put enough efforts and do the homework and even do extra homework, maybe you're able to get a 95, 93%. You know, that's possible. Okay. And I know some of you are very busy, so it's really a challenge. Okay. So when I was undergraduate, every semester I had to take how many courses? 3 math courses, 1 English, 1 politics, 1 sport. It's like 6. Yeah, that's not a lot. Okay, because that's the courses, 3 math courses. Yeah, I did almost all the homework. Not the signed homework. I just looked at the back side of the book. Oh, I'd finished 10. Then there was 30 problems left. I did all the 30 problems. Okay, if I can finish it before 5 o'clock p.m., then I went out for sports. Even though I said to stay in the dorm. Okay. Yeah.